you have a series of problems asking what's the best solvent for dissolving lipids or waxes or steroids. And in each case, you need to remember that lipids, waxes, and steroids are all highly nonpolar molecules. Lipids typically have long hydrocarbon chains with just small polar groups. Waxes are the same. Steroids, you're going to need to memorize this ring shape so you recognize it as a steroid. 3 6-membered rings connected like this, and 1 5-membered ring. And they can have all sorts of things attached around it. They can sometimes have double bonds inside of the 6-membered rings. But this 6-6-6-5 shape is giving you a steroid. And all these are very nonpolar. So to identify what's going to be soluble in a particular solvent, we need to look at the strongest intermolecular forces in that solvent. Water is dominated by hydrogen bonding. An 8% sodium chloride solution implies water, so we have hydrogen bonding, but we also have ions in that water. That want to do ionic bonding. Trichloromethane and tribromomethane, and even things like, in some ways even dichloromethane, all of these are barely polar. So they form dipoles, but weak dipoles. They don't necessarily mix with water very well, although they do a little, but they are going to dissolve lipids, waxes, and steroids quite well. Here we have octane. This is nonpolar with its London dispersion forces. These induced dipole forces that are weak and very weak and temporary. And then diethyl ether, we can draw that. It's got our 2 ethyl groups on each side of an oxygen to make it an ether. This also is just a little polar. So which things will dissolve fats well? Water will not dissolve fat well. Will not dissolve waxes, will not dissolve steroids well. You add salt to it, it will dissolve nonpolar things even worse. Whereas these halocarbons, these small halogenated solvents, yes, nonpolar solvents like octane, that'll dissolve them the best. Ether, a little bit polar, also dissolves lipids, waxes, and steroids.